Hi guys, I want to talk to you a little bit about the periodic table. So what I'm going to do is I'm going to talk about the basics of the periodic table, and then I'm going to go into more specifically metals, non-metals, and metalloids, okay? So here, this is the periodic table in pictures, and what you've got is a picture for something that element can be used for. The periodic table, remember, is an organization of all of the ingredients that exist in the entire universe. But what you're doing is you're putting these ingredients together in different ways to make different things. For example, you are made up of a certain number of these elements, mostly carbon, and then your refrigerator is going to be a bunch of metal parts. So it's different elements from the periodic table, and they're all put together in different ways to make you, or to make, your school desk or your book or things like that, okay? The periodic table is arranged into periods and groups. We have 7 periods in the periodic table, and those are the horizontal ones. And the way that I remember this is I think of how many periods we have at Memorial Junior High. We have 7 periods. And there are also 7 periods on the periodic table. So hydrogen and helium are in period 1. Then I have lithium and beryllium, and then going across this way, boron, carbon, nitrogen, and so on are all in period 2. And then I keep going down the periodic table until I get to the bottom, which is period 7. I have 18 groups or families on the periodic table, and those are the columns. And that's like the My Periodic Table assignment that you're doing, where you have to create your own periodic table, and you had to come up with 8 categories, I think it was in the assignment. Well, here in the periodic table, we have 18 groups and families. And so those are my vertical columns. So all of these right here, hydrogen, lithium, sodium, going down this way, are all in group or family 1. And they have things in common with each other. You will learn more about this as you get older and go into chemistry in high school. Then I have group 2, 3, 4, all the way to group 18 over here where helium is at. Now let's talk about the types of elements that we have. We have 3 types of elements, and they are metals, non-metals, and metalloids. And so over here, I have another poster that I want to show you. Okay, so here I have the periodic table again, but this one is colored by metals, non-metals, and metalloids. And those are my 3 basic categories of elements. You'll notice that the metal ones, which are purple on this periodic table, are the largest group, and they are mostly to the left side of the periodic table. The properties of metals are going to be a good conductor, malleable, ductile. They're usually silver or gray, and they are going to be lustrous or shiny. That's the metals that are right here. So let's talk about those properties a little bit more, and I want to show you some stuff having to do with those properties. Now, malleable means that it can be shaped or flattened easily. A really good example of this is aluminum foil. So you can take a piece of aluminum foil and wad it up and then hammer on it to flatten it into a sheet. That means that it is malleable, it's bendable, it's, you can shape it. Another thing about these elements, these metal elements, is that they are ductile. That means that they can be shaped into wires. So think of electrical wires or fence wiring. You can actually shape it and bend it and create a wire using metals. Good conductors mean that they can conduct heat and electricity. That's why we use metals for pots and pans, to cook our food, because we know that it's going to get hot and it'll cook our egg. Another thing is electricity. Think about your cord that you use to charge your phone. It's got metal wires on the inside, right? Because that's where electricity is going to travel through. So I'm going to show you a circuit. A circuit is basically a bunch of wires connected to a power source. In this case, it's a battery, and you can connect the wires and a little light bulb will turn on. And you can put something in between there, like a metal. And so I'm going to take a piece of aluminum foil and put it into my circuit. And then you will notice that it will have the little light bulb turn on. But if you take something that is not metal, in other words, something that is a bad conductor, like a piece of paper, and put it into that circuit, it is not going to work. The little light bulb will not turn on because it is not a good conductor. So metals are good conductors. Another thing about them is that they are going to usually be gray, silver. There are some exceptions, like gold, you know, it's obviously a yellow color, but most of the metals are going to be silver or gray. Another thing about metals is that they are shiny for the most part. They're gonna, you know, be that silvery kind of shiny substance. Now let's talk about non-metals. Non-metals are the total opposite of metals. They are on the opposite side of the periodic table, and their properties are going to be totally opposite of the metals. They are going to be bad conductors. So non-metals are going to be used for something called insulation, or they're going to be insulators. Think about that charging cable that you have for your phone. It's got a plastic coating on the outside, right? Because you don't want your charging cable to get hot, so they'll put an insulator on that. Or think about a pot or a pan that you have at home that has a wooden handle, and you can grab that. Even though the pot or the pan is hot, you can grab that wooden handle because it's an insulator, and wood is mainly carbon, and so it's a non-metal. It's not going to get as hot as a metal would. We don't want to touch hot stuff, right? So we use non-metals as insulators. Non-metals are not going to be malleable or ductile. They are going to be brittle. You might have had a piece of candy called peanut brittle. Brittle means that it breaks. A really good example of this is a piece of chalk. If you take a piece of chalk and you hammer it with a hammer, it breaks apart. So non-metals are brittle. You cannot shape them. Like you shape metals, if you hammer a metal, it changes shape, but it still stays, you know, together. It doesn't break. Non-metals will break because they are brittle. Non-metals are also going to include some gases and some solids, but you've mostly got your gases on the very far right-hand side over here. Okay, so metalloids are here in between the non-metals and the metals. Metalloids are like your friend who can't decide, you know, they're like really bad at making decisions. Metalloids have properties of metals and they have properties of non-metals. For example, they are okay conductors, or what's called semiconductors, meaning they can conduct heat and electricity, but they're not as good as at it as metals are, but they're also not as bad as non-metals. They can be shiny or they can be dull, it just depends, and they can be malleable and ductile. So they, again, are the ones that kind of don't fit into any group. They're kind of in between. Let's talk a little bit about hydrogen. Hydrogen is also a non-metal. Now, this gets a little complicated, and you'll learn a little bit more about this once you get to chemistry. But even though hydrogen is a non-metal, it hangs out over here with the metals that are in group 1 because it has a lot more properties that are in common with those guys. So think of like that family member that you have that maybe doesn't fit in quite as well as everybody else. That's kind of like hydrogen. One example of a metal is gallium. And like all metals, it has the properties of metals, right? So it's kind of gray, silver, it's shiny, it's a good conductor, it is malleable. And another thing about gallium that's really cool is that it has a very low melting point. So you can actually hold this in your hand, and after a while it will melt. But what I'm going to do is I'm going to put it into some hot water. Here's gallium a little bit after I've let it melt a little bit. So you can see that there's still some solid pieces in there, but some of it has started to melt already. So what I'm going to do is I'm going to take this little silicone mold and I'm going to pour some of the gallium in there. There's your liquid gallium. And after a while, it will become a solid again. And here's what it looks like once it is solid. That's gallium. Okay, thank you guys for watching, and I will see you guys at our next meeting. Bye.